In this chapter, we're going to be discussing another data structure, the array. The array is similar to the list, except for one major difference, and that difference is that when you create an array, you have to tell the compiler the size of the array when you declare the array. And then once the array is set to that size, it can never change, unlike a list that can grow as you need it to. With an array, you're mostly limited to the size of the array when you declare it. So in this lesson, we're going to look at how to declare arrays. So let's start off by looking at a couple of examples. Let's say we want to create an integer array of numbers. The way we do that is we start with the data type, followed by a set of open and closed brackets, followed by the name of the array, we'll call it numbers, followed by an equal sign, the keyword new, the data type again, an open bracket, and the number of elements that you want, like so. So here I'm saying I want an array named numbers, and it will hold 100 integers. So I can work with another data type. I can write string names equals new string 10, boolean values equals new boolean 2, char letters equals new char 50, like so. Those are all valid array declarations. Just as with the list though, if we want to initialize our array to a set of data in advance, we can do that. I'll show you just a couple of examples here. For numbers, we could write int nums equals new int, and then after the open and close parentheses, I'll put a open curly brace, and then we can write our list, like so. I could do the same thing with characters. The thing to remember about a list is you have to delimit each element with a comma. I'll stop with this example because you get the idea. And then close the list and then a semicolon. So those are the two ways you declare arrays. Either with just the number of elements you want to store in the array, or with the actual list of elements themselves. And of course, that's telling the compiler how many elements to put into that array. When you're looking at the positions of an array, you always start with position 0, or we also call that index 0 or even offset 0. So that in my nums example here, the number 1 is at position 0, number 2 is at position 1, number 3 is at position 2, and so on. So the last element of the array, sometimes also called the upper bound, is always going to be one less than the number of elements in the array. And like with lists, that's important when we're looping through an array. We have to be very careful that we don't go beyond the end of an array when looping through it, because that can lead to an error. So again, those are the two ways that you can declare arrays, and we'll finish the lesson there, and we'll move to the next lesson where we're going to demonstrate ways to access and work with the elements in an array. In this lesson, we're going to look at a couple of different ways of working with arrays, how to access the elements, and some other just basic techniques of working with arrays. First thing we need to do is create an array to work with. Let's create an integer array, call it numbers, and let's begin by assigning it a list of data. We'll do 10 integers 1 through 10 as the beginning array elements. The elements of an array are accessed using subscript notation, just like we did with list elements. So for example, if I want to determine the sum of these elements, I'll write a for loop that starts at 0, and then we'll go through the length of the array. So I can use length. That's a property that's part of the array class and is available to any array object that you create. And then I can write sum plus equal numbers sub I. So that's the most important thing to see there, is that we use the subscript notation to access an element of the array. And then just to complete the program, we'll display the sum. Of course, I can directly access any elements that I want. So if I were just trying to sum, say, the first 2 elements, I might write the program like this. Let's comment those lines out. And 1 plus 2 is equal to 3. So that's right. Let's look at an example where we create an array in a loop. So we're going to comment out these lines that we've already used. We'll save them for later. Yes, we don't need sum anymore. Let's just delete that. So let's create a new array. an array of 10 elements. Before we write the loop, let's create a random number object. Now let's create the array using direct access in a loop to assign the initial elements. And again, we'll use the length as our means of stopping the array, a good property to use when looping through an array. Then we'll plus I, and then we'll say numbers sub I is equal to rand next, and we'll say 101, like so. Then we can display the elements, same process. We'll put a space in between them, and let's run the program. And there are our array elements. If I want to compute the sum, again, very simple. Sum plus equal number sub I. We can write the sum out. If I want to compute the average, let's get rid of the sum. Again, I can use length as a means of determining the average. And the average is 42. We probably want to display it again, so let's copy a loop, add it in after we initialize the array, and let's write those out so that we can see the elements to determine if that average looks correct or not. Hard to tell when we don't know what the array elements are. And we need a console write line in between here, put a blank line. So we'll do that. And there's our whole program. Let's run it. And the average 63 is probably correct, looking at some of these 23s and 92s and 97s and 56s. So we've demonstrated most of the common techniques used in accessing arrays. So we'll wrap up the lesson at this point. What I'd like to do in the next lesson is talk about some special array methods that will make our work a little bit easier that have something to do with array element access.